Bismillahirrahmanirrahim. Welcome back to this video session of final exam revision. In the last video, I did explain from this exam paper, that is from the Spring 2015 exam paper, uh, the first two parts, that is part 1 multiple choice questions and part 2 with short answers and some finding the calculations or doing some calculations over there in part 2. For example, finding the big O's and finding the pre-order in order for the trees and about the stacks. Okay, now inshallah in this video I'm going to explain you the part 3, in which you have some programs and some insertion, some sorting techniques. Okay, so in this one you have around 3 questions, I believe 3 or 4 questions. Okay, so let us discuss it one by one. Question number 1 says write a recursive method called GCD. You need to write a method by name GCD. Okay, that takes two non-negative integers m and n, where m is greater than 0 and n is greater than or equal to 0, both not both equal to 0. Okay, and returns the greatest common divisor GCD of these two numbers. Okay, now here you are asked to write a method GCD. So it's a method by name, let's say call it as in GCD. I'll write it here, a method GCD. Okay, now it takes two non-negative integers, that is m and n. So it takes two integers, int m comma int n. Okay, and it returns the GCD of this number, the greatest common divisor. So its return type is integer int. Of course I am going to add this public static int GCD of int m comma n. This is your method. You start your method from here. Now the base case and the recursive case are denoted here. You need to write the program according to this given cases. The base case is if if n is equal to 0, then you have to return m, then the result is m. So if directly you can write if n is equal to 0, return m. Otherwise what you have to do, you have to again call the same GCD recursively, n comma m mod n. So you call the GCD again the same method recursively, n comma m mod n. Okay, so it is in else part, else return GCD of n comma m mod n. I'll just write it more clearly over here with the else return GCD of n comma m mod n. Okay, this is the method. Okay, and you will take 5 marks for this method. So a very simple method, just you need to implement this, the given cases over here, into a program code, into a Java code. Okay, number 2, this is part A of question number 1. Part B of question number 1, write a method called second. Now here it is asked you to write a method called second. That takes a stack object s, that takes a stack s as a parameter and return the second element in the stack just under the top. Now here it is talking about the stack. We all know that the stack is something in a fashion of last in first out. Whatever we insert here, go on inserting. For example, let us say the stack value 1 2 3 4 5. The top of this stack is this one, and if you want to take out the values from the stack, you take it from the top. Okay, so there are different methods for this. There are different methods or different functions related to the stack. Those are push. Push, it means inserting into the stack, like inserting a new value into the stack by using the function push. Pop, it means removing the top value and setting the top to its next value. Okay, it is called pop. And peek, it will just give you the topmost value. Peek will just give you the top value, but it will not remove the value. The peek will just give you the top value, that is 5, but it will not delete the value or remove the value from the stack. Okay, now here this function takes a parameter s, that is a stack, and returns this second element in the stack, that is just under the top. So for example, if this is a stack s, the second element is 4. Now your function should return us this 4 value, okay, leaving the stack unchanged. The stack should not be changed, okay, or the stack should be as it is. Okay, you can use the methods given over here. There is a empty method, there is a push, pop, and peek method. Now what else, what we need here in this function? This function returns the value. So for example, let's say this is a stack of integer values, so we'll take it here as integer, its return type as integer. Of course you need to add public and static and this is your method. Okay, now first of all we have to take this value. So first we need to take it out, pop it out. Let us take into a temporary variable this pop int t is equal to s dot pop. So this will delete this 5 and t will have the value 5. Okay, then int x is equal to s dot peek. Now this peek will give you this value because this is already taken out, okay, by this pop. Now your top is over here. Peek will give you 4. So x, no, this is 4, this is the second element you need to return. Okay, then after this you need to push this 5 again so that your stack will remain as it is. Okay, so I will say push of t, s dot push of t. T is 5, which we have taken into a temporary variable. Okay, so it is pushed again to the stack. Now 5 will come again its place. Okay, now after this you have to return x, that is the second element, 4. So 4 is returned back. Okay, so this is your method. This will give you 5 marks in your exam. Okay, okay, moving ahead next to question number 2. Now, question number 2 is again a program. It says write a Java method that take a stack s, and 2 arrays odd and even. So there are 3 parameters here, s and 2 arrays odd and even. Okay, and fill the array odd with odd numbers from a stack and array even from even numbers with the stack in this stack. Okay, now you need to take the elements of the stack if the number, for example, let's say this is your stack. You have 1 2 3 0 4. This is your top of this stack. Let's say this is stack s. The question here is fill the elements of this stack into this array, odd and even array. Let's say this is an odd array and this is an even array. Fill the elements. If it is an odd element, insert into the odd array. If it is even element, insert to the even array. So first is 4, it is in even. Then next is 0. Note that 0 should not be filled, so this should be done when the top is not 0. Okay, when the element is not 0. If it is 0, you not to insert. Then next 3 is an odd, will be inserted into odd. Next 2 is an even, will be here. Next 1 is an odd. So this should be your output. Okay, so here note that 0 should not be filled in an array, and the stack should be at the end as it is initially. We need to return back the stack values as it is. Okay, so here it takes three arguments, stack and odd and even. Okay, now let us create a temporary stack in which we are going to store these values when we pop it out, because when you want to check the values, every value, you need to pop the values from the stack. So for this reason, we got to take another stack, for example S1, and in the S1 we need to push these elements when we do pop it out. Okay, so that's why in a stack S1 is taken over here, and two variables are taken I and j, one for the odd and another for the even. Okay, or you can say one for the even, the other for the odd. Now until when we need to process this, until the stack is empty. When the stack is not empty, you go on doing this process. So we take a while loop while s dot is empty, not of it. Okay, s dot is empty, not of it. When not of s dot is empty, because is empty will return true when the stack is empty, but initially the stack is not empty, then this will return false, and this not will make it false true, and then it will get inside. Then we pop the first element into a variable x. Okay, and we check for if x is equal to 0 or not. Okay, so if x is not equal to 0, then we check whether it is an even number or odd number. Here, if x is an even number, how do we check even number? We are going to mod with 2, and if the remainder is 0, then that is an even number, otherwise it is an odd number. So we check here, if x mod 2 is equal to 0, then it is an even number. So you insert in the even array, even of I is equal to x and I plus plus. Here in this statement, these two statements are joined in one statement. Even of I plus plus is equal to x. Both are true. I, we are starting from 0, so even of 0, that is even of 0 will be 4. Okay, and then again we are going to s1 dot push of x. This x value, that is 4, we are going to push in the s1 stack. So here 4 will come in the s1. Then again it will repeat back, go back to the while loop and check for whether it is empty or not. 4 we have taken, pop it out. Then we pop for 0. Okay, 0, now 0, x is not equal to 0, this become false. So we just come out of this if and do push it into the s1. Then again it goes back to the while. Now it will pop 3. Okay, pop 3. Now x becomes 3 here. Then it is not equal to 0. X mod 2, 3 mod 2 is not equal to 0. Then it will go for the else, and it will insert in odd of j. J is initially 0. J did not changed. Okay, I changed previously to 1. J remains it. J is j of 0. Odd of j is equal to x, which is 3. So in the odd array you get 3. First element. Then you say j plus plus. Okay, so increment j to 1. So here these two statements are given in one statement. Okay, then again it will insert 3 into the s1. Then it will pop s2, going back to the loop, again pop the stack value 2, and then check for not equal to 0. It is true, it is an even number, then insert over here 2. So 2 is inserted, and I is incremented to 2. Okay, then push it into the S1, then pop 1. Now the stack is empty. So after you pop 1, 1 is not equal to 0, true. 1 mod 2 is equal to 0, false. Then it is an odd number. So insert the odd number over here. 1. 1 is inserted here. Incremented j becomes 2. And 1 is pushed into the S1. Okay. So here you got the odd array and you got the even array. Okay. And this condition become false. The loop will come out. The loop will come out. Okay, now you need to restore this S1 back into the stack S. So what we do, we'll put a while loop while S1 dot is empty is not, that is not of S1 dot is empty, or we can say S1 dot S1 is not empty, then pop S1 and push into the S. Okay, so pop 1, so let's say this is S, pop 1 and push into S. So it will come 1, then 2, then 3, then 0, then 4. Come 4 over here. Top will be 4. So you find the same S, the initial S, 40321, 40321. Okay. So this is how this program or this method is written. This is about the question number 2. Now moving ahead to question number 3, it talks about a binary search tree. Okay. Now here it is asking you, there are 2 questions in this one. Draw a binary search tree that result from inserting the value from 1 to 7 in the following order, in the given order. In this order you got to draw a binary search tree indicating the height of the tree. That is, you need to mention, after you draw the tree, mention what is the height of the tree and what are the number of nodes at level 2. Okay. Now how to draw the binary search tree? There is a specific method to draw the binary search tree from a given set of values. For example, this is the given set of values from 1 to 7, 5, 3, 7, 6, 2, 1. The first value will be considered as the root. So 5 is our root. Then we'll check for the next value. If the next value is smaller than the root, we take that value onto the left of the root. Otherwise, we take it onto the right of the root. So 3 is smaller than 5, we take it onto the left of the root. Clear? Then the next element is 7. 7 is larger than 5, we take it on the right of the root. Then next value is 6. 6 is larger than 5, we take it onto the right. Then we compared with the 7. Now 6 is smaller than 7. If it is smaller, take it onto the left of it. Because every time you add an element, you check for the values, whether it is greater or less. If it is lesser than its parent or its root, then you take it onto the left. If it is greater, you take it onto the right. So the next element is 2. 2 is smaller than 5. It comes to here 3. 2 is smaller than 3. Then it is added to its right. Then moving to 1. 1 is smaller than 5. 1 is smaller than 3. 1 is again smaller than 1. Then it will be added to the right of the 2. Then 4. 4 is smaller than 5. It will come here. But greater than 3. It will come onto the left of it. So 4 is here. This is your binary search tree, BST, for this given order list. Now indicate the height of the tree is the maximum height of the nodes. So what is the maximum height is 1, 2, 3. So height of the tree is 3. What is the number of nodes at the level 2? This is your level 0. This is level 1. This is level 2. So how many nodes are there in level 2? 1, 2, 3. So there are 3 nodes at level 2. Clear? Now after this, this is part A of question number 3. Part B of question number 3 says that draw the BST in part A after of each of the following operation. That is delete 3. Now you want to delete this 3, node 3. Okay. Now in a binary search tree, what is the condition or what is the procedure to delete a node? First of all, we check whether this node is a leaf or not. If it is a leaf node it means that does not have children. For example, here this is a leaf, this is a leaf. Okay, these are leaf nodes. If it is a leaf node, just delete it. Okay, there is nothing to do, just delete it. If it is not a leaf node, then replace the largest value on its left subtree, or replace the smallest value on its right subtree. Okay, now this is your tree, you have here 5, 3 is over here, you want to delete 3. Either you replace the smallest value onto the right, from the right, that is 4, or you replace the largest value from the left. Okay, so from the in the left you have largest value 2, the smallest value onto the right it is 4. Okay, you can replace any one of it and delete what you are going to replace it. So if I replace this one, this is a leaf, if I replace this one, this can be easily deleted. Okay, so if you have to replace this in this place and you have to delete this one, so your tree will be something like this: 5, 4, because 4 is replaced here after deleting 3, then 2, then 1, and onto the right it is 7 and then 6. Then delete 5. Now 5 is root here. In the same fashion, either replace the largest value onto the left subtree or replace the smallest value onto the right subtree. Now if you see the largest value onto the left is 4, and then it has other children, but here the smallest value on the right is 6, which is a leaf. So you can replace this very easily and delete this one. Okay, so your tree will be something like this. In the place of 5 it will come 6, it is replacement, 7 over here, then 4 over here, 2 and 1. Clear? Moving ahead, add 3. Now adding the element to the tree is the same fashion how you have created by using this one. Okay, 3 is smaller than 6, take to the left, smaller than 3, again come to the left, greater than 2, so add here 3. This is the tree after adding 3. So this is the tree for this question. Okay, moving ahead, these are the given answers for you. Moving ahead to question number 4, it's about the selection sort and the insertion sort. The given is the list of strings and you are asked to sort this list by using the selection sort and the insertion sort. Selection sort says that you have to find the smallest value, okay, and replace it with the first element, and then find the next smallest value, replace it with the second element, and next find the next smallest value, replace it with the third element, and so on. Okay, now this is the list. What is the smallest value in this list? The smallest is WEAR, where, because you see here there are the words from W, Y and Z. In W there are 3 words with WE, WE and WE, all are same. After WE there is R, S and A. A is the smaller one, so this is the smallest one. So replace this with the first two. Okay, so in this second list you find where in the first, and this is the first element in the last. Okay, now here again you check from here, replace the smallest here is where, so replace this with this second element, so it will come over here. So this is your sorted list. Now again in this one replace the smallest, so here of course WEST is the smallest, will be replaced here, so this is the sorted list. And in this one Y is the smallest, will be replaced here, this is the sorted list. And in this this is the sorted list, and in this two ZE, zebra, is the smallest one, will be replaced, and hence you find the sorted list for the given words. This is in selection sort. Moving to the insertion sort. Insertion sort says that Consider the first element as sorted and compare it with the second element. If the second is smaller than first, then swap it. Okay, and then check for the third element. The second is checked with the third element. Then if it is smaller, swap it and again check back with the first element. If it is again smaller than the first element, then swap it. Okay, now let us start with this one. The first element as sorted compared with the second element. Okay, both are there is no change because the first is smaller than the second, because R is smaller than the S. Okay, so it remains as it is. Now the second is compared with the third. There is no swapping because the second is smaller than the third, so it will remain as it is. Now here the third is compared with the fourth. There is no need to swap because yo-yo is smaller than zebra. Then zebra is compared with zoo. Okay, then zebra is smaller than zoo, it remains as it is. Then zoo is compared with where. Now here where is smaller than zoo. Okay, then you need to swap it here. So there is a one comparison, one swapping. Then again where comes here and zoo comes here. Okay, then where is compared with again zebra. Now zebra is smaller than where, then zebra is taken here and where will come here. Then where is compared with yo-yo. Yo-yo is greater, zebra is smaller. I'm sorry, the where is smaller, so where yo-yo is taken and where will be here. Then now where is compared with the west. Again where is smaller than west, so west is taken out and where will be here. Okay, and then where is compared with the were is greater, where is smaller, then it will be swapped, compared and swap, and were will come and where will be here. So hence you will get the sorted list. Now here the question B is, what is the total number of swaps and comparison in insertion sort? So how many comparison you did? You did one comparison here, so it is one comparison, is one comparison, here one comparison, and here one comparison, and here here 5 comparisons. How? Where with zoo, then again where with zebra, 2, 3, 4, 5 comparisons. So here 5 comparisons, and here also 5 swapping. One swap because where is swapped with zoo, then again where is swapped with zebra, 2, 3, 4, 5 swapping. So hence you have 9 comparisons and 5 swappings. Okay, so this was the last question in the exam paper. Okay, so hence we are done with this, and hope this will be very useful for you to prepare for your final exam. So if you have any questions, you can send me an email. Write to my email your question or your doubt, and I will be happy to answer you. Thank you very much for watching the video.